Welcome back. Today in this video, we are going to see the Spring AI Parallelization Workflow. So earlier in our Spring AI Workflow pattern series, we discussed about the chain workflow. Today in this tutorial, we will discuss about the parallel workflow. So when it comes to the Spring AI Parallelization Workflow, what we do is based on the input that we receive from user, we make the parallel calls to the LLM, and once these calls are completed, we aggregate the result and then send the output back to the user. So this is how parallel workflow pattern works. So when it comes to parallel workflow, there are two variations of this workflow. First one is the task decomposition, wherein what we do, we break down our problem into the independent subtasks, and what we do, we submit each of the subtasks to an LLM in parallel, which means we are executing each of the subtasks parallelly. And once these subtasks are completed, we aggregate the result and send the result back to the user. One of the simple example for this is, let's say we want to summarize a book. So what we do, in order to solve our problem, we break down the book into different chapters, and then we will process each of the chapter concurrently and then summarize them. And once all the chapters are analyzed, we aggregate the result and send the result back to the user. So here you can see, next we have the next variation is the voting or consensus type of workflow pattern, wherein what we do, in order to solve our problem, we send the same input to the different LLM instances in parallel, and once we have received the output from all of the LLMs, we analyze which is the best answer generated by LLM. Let's say you want to generate a technical article, you send an input command to different LLM models like Claude, ChatGPT and Grok. So once we have received the output from them, we analyze which one is the best out of three and select that answer as the final answer for our problem. So coming to the implementation part, what we are going to understand today is the simple news aggregation application, wherein we will summarize the different article from different categories. And what we will do, in order to summarize this article, we will make use of parallel workflow. Since we have different articles under different categories, those can be processed concurrently, and once the summary of these articles is ready, we will aggregate and send the response back to the user. So this is how the overall project structure will look like, wherein at the root we have the name of our application, Spring AI Parallel Workflow, and inside which we have controller, service and the workflow class, which will actually, wherein the parallelization workflow implementation has been added. Then we have the Spring Boot main application class. Then we have the application.yml and project.xml, wherein the configuration has been mentioned. So coming to the IntelliJ, here you will see we have the pom.xml. So coming to the pom.xml, we have added three different dependencies like Spring Boot Starter Web, which will help us to develop the REST API for our application. We have added Spring AI Starter Model OpenAI, which will be useful for interacting with the LLM. In our case, we will interact with the Google Gemini APIs. We will come to the configuration part, and then we have added the dependencies related to the logbook, which will useful for logging the HTTP request and response that we are sending back to the LLM. So in order to understand the parallel workflow, we need to see whether the calls that we are making to LLM are actually going in the parallel forms, for which this logbook library which will be useful. Then we have the Spring AI bomb dependency, which is useful for managing the Spring AI related dependencies. Now coming to the application YML, here you will see we have added the configuration related to AI, wherein first is the API key, which we are getting from our environment variable. Then we have the base URL. Since we are making use of Google Gemini APIs, here we have configured the same. Then for Gemini APIs, we have configured the URL path, and the model that we are using is the Google Gemini 2.0 Flash Experimental. Next, we have the logging related configuration. wherein since we added the logbook dependency, in order to see the logs, we have set the log level to trace. Now coming to the main class, which is the starting entry point of our Spring Boot application. Here you will see we have just added one bean related to REST client customizer, wherein what we are doing is we are adding one interceptor which is related to logbook and which will help us to log our API calls that we are making to the LLM. So this is just a simple configuration to enable the logging in our case. Now, in order to understand how our application work is, we will quickly go through these different class. We have the controller class, which will make a call to the service class. Service class behind the scenes make a call to the workflow class, wherein the actual parallel processing is happening. Now coming to the controller class, we have created one simple endpoint which is starting with API news, and the path that we have created is summarize. This is going to be a get type of endpoint, wherein what we will do, we will get the summary of different articles that we have for different categories. So here you will see we have configured the news service inside the, we have injected the news service class. Here you will see constructor injection is being performed, and this endpoint, which is summarize endpoint, is making use of service class to summarize the news. Now coming to the service class, here you will see we have the summarize news method, wherein first we have the summarization prompt. Since for each article we want to instruct our LLM to perform the summarization, first we are getting the summarization prompt. So if we see the content of this, here you will see we have written that for the article that we have supplied, generate the news content in 2 to 3 sentences. So this is the just a summarization prompt for LLM. Then we have the news content. So in order to summarize the news, we have created some dummy content with different categories. So if we see the content of news content method, here you will see we have a map of string comma string, wherein this one is the category and this is the sample article. So we have different categories like technology, sports, business and health, and for each category we have just added some dummy article inside each of the category like sports, business, health and so on. So now we have the summarization prompt, we have the news content. What we will do, we will now make a call to the parallelization workflow method, which will actually summarize these articles. But before that, here what we have done is we have separated the categories and articles. Since we will only be sending the articles to LLM to perform summarization, this is where this will be useful. So before summarizing the article, we are logging the start time, and once the processing is completed, we are calculating the end time and we will send it back to the user. So now we have the articles, we will call the parallelization workflow class, wherein there is a parallel method. What we are passing is the prompt that we have. We need to instruct the LLM that we want to summarize these articles. Then we have the list of articles and the number of workers, in our case is 4. So now once the processing is completed, what we are doing is, based on the summaries that we got, now we need to send it back to the user. So what we have done is we have created the map of string comma string, wherein for each category the summaries of article will be entered, and finally we will send the response back to the user, which will contain our summarized articles, the processing time it took to complete our operation, and the number of different categories that we have. Now coming to the main part, which is the workflow class, which is actually performing the parallel processing. This is where you will see we have added the chat client. Chat client is something which using which we can interact with the LLM. So here you will see we are initializing the chat client with the help of chat client builder, which is supplied by Spring AI. So all we are doing is chat client builder.build, based on which chat client will be initialized, and now we are ready to make the LLM calls. Then we have the parallel method, which is being called by the news service. Here we will see the prompt, we will receive the prompt, we will receive the input articles, and the number of workers that we have seen earlier was the 4. So in this method what we are doing is we are making use of the multi-threading. With the help of executor service, we are creating a pool of threads and we are initializing the pool with the 4 workers. So if you remember, the while calling the parallel method, here we supplied the number of workers as 4. So when we will create a thread pool, what we will do, executors dot new fixed thread pool, and the number of threads inside this pool will be 4. So once the executor service or thread pool is created, what we will do, list of articles dot stream, and for each article we will create the completable future using which we will make a async call, and based on the results received, we will aggregate it. So here you will see completable future dot supply async. What exactly this is doing is, it is supplying the task of calling the LLM to the executor service, and executor service will delegate this task to the threads that we have inside the fixed thread pool, and they will execute these calls parallelly. So here you will see completable future dot supply async, and what operation we are performing inside this is, we are calling the LLM. Here you will see chat client dot prompt, we are calling the LLM, and once the response is received, we are basically storing it inside the completable future of string. So while calling the LLM, here you will see we are passing the prompt that we have seen earlier, that generate the summary of article in 2 to 3 sentences, will be passed here. The input is single article. Here you will see we are making use of stream, and for each article we are creating the completable future, then we are submitting it to the executor service, which will execute each of the task in parallel. So once this is done, we have the list of completable futures, and what we will do, we have the list of future, we will make use of stream, then we will wait for each of the task to be completed, and once each of the task is completed, we will get the result. When we say task, this is nothing but it is summarize, LLM is summarizing the articles that we have submitted, and once the all tasks are completed, we are collecting it back to the list. Inside the list we will have summary for each of the articles, and based on which we are constructing the response that we have seen earlier. Now let's see this in action. So when we run our application, so our application is started. Now when we go back to Postman and call our API, which is API new summarize, behind the scenes it will make 4 parallel calls. We will see it in action. So by the time we receive the response, here you will see with the help of logbook we can see this detailed log. The first log is related to the request that we have received from Postman, which is API new summarize, and then next you will see we have the 4 parallel calls. So here you will see we are making calls to Google Gemini chat completion endpoint. So we have 1, 2, 3 and 4. So these calls were performed parallelly, and based on this you will receive, we might have received 4 responses. So this is the first one, this is the second one, and here you will see we have the third one, and then we have the fourth one, and finally we have the fifth one. Fifth one is nothing but the aggregated response that we have created and that we are sending back to the user. So fifth log is related to that. Now when we go to the Postman, here you will see since we were sending the processing time, it is logged here. For each of the articles we have received the summaries under each category. Here you will see we have the summary for each of the article, and the number of categories that were processed were 4, like we have seen in our dummy content. So this was all regarding the parallel workflow. We have created the detailed article for this, which you can go through. Also the example that we discussed in this tutorial is also present on GitHub, so you can try and run the code if you are interested. So yeah, that's all from my end regarding the Spring AI parallel workflow. I hope this was useful. Thank you.